Welcome, ladies and gentlemen, to the forum of the group exhibit Hydrogen, Fuel Cells and Batteries. Welcome to the next talk here in the forum. We will talk about electrolyzers from Hydrogenics, and our topic is large-scale energy storage, power to gas, power to fuel, and we will talk with the Managing Director of Hydrogenics GmbH, Dr. Bernd Pitschak. Here he comes. Please give him a big hand. Dr. Pitschak, good to have you here. Have a seat, and everybody is invited to well, have a drink on the house and to ask questions if you want to. So just raise your hand whenever you have a question to Dr. Pitschak. Dr. Pitschak, the German energy transformation, the German Energiewende has changed the game a little bit for electrolyzers, didn't it? So there's probably a big possibility to earn a lot of money in the future. What do you think?
We hope so, but generally speaking, yes, it has changed a lot because the influence of the renewable has increased, and this has led to some flexibility in the grid, so power is generated when wind and sun is shining, not necessarily when it is consumed as it was before. So the storage of energy becomes more important the more the renewables come to the grid, and that's a base idea behind what we call power to gas, or that generally spoken called power to gas, where you have the chance to link the electrical side of the grid plus the gas grid, for example, by the use of electrolysis, where you transfer electricity via electrolysis into a gas, into a hydrogen, which then can be used for different processes behind.
Let's focus on this power to gas a little bit. So we have a lot of renewable energy in Germany, also in Europe, in many places. And we just can't use it, because if you produce electricity, you have to use it immediately. So at night, when nobody needs energy and the wind is blowing, nobody uses that energy. We could make hydrogen from that with your electrolyzers.
Yeah, that's true, and we actually do that in more than 8 demonstrations projects throughout Europe in the megawatt scale, just to show that the technology is capable of doing that in combination with renewables, which have a certain attribute. They are very flexible, so they have ramp rates. They're available or not available. It's different or difficult to control, and of course the electrolyzer has to cope with the behavior of the renewables, and the demonstration projects look in all the various aspects the electrolyzer has to cope with and prove that the technology is ready and designed for it.
So the hydrogen is just the energy carrier, the carrier of the energy of the renewables that are not used at certain times. And what do you do with that? You could drive a car with the hydrogen.
Yeah, first of all, we transfer the electrical energy in a chemical-bound energy carrier, which has then a higher energy density as, for example, compressed air, which is only potential energy, or hydropower, which is also potential energy only. That's one thing, that you have a more compact energy carrier. The other thing is that hydrogen itself has its own values and can be used in different ways. Of course, you can run hydrogen directly in a fuel cell. For example, in fuel cell powered cars, as it acts as a fuel. It can be sold via the fueling station. You can use hydrogen as a chemical component, which is as a raw material used in several industries. You can use hydrogen to reduce the carbon footprint of natural gas if you blend natural gas with hydrogen and distribute it, which is done, for example, in Falkenhagen, where we inject the hydrogen into the natural gas grid, into the ONTRAS pipeline, and then transport that gas down to Switzerland, where Swiss Gas is taking that gas, for example. Of course, you can further go with the hydrogen and do a methanization and create synthetic methane, which is then totally available and absolutely open to the gas world with a no carbon footprint on it, and you come to a so-called renewable gas. You can further transfer hydrogen into methanol by using CO2 and then run it into methanol, and you have a liquid which you can blend with gasoline for biofuels, for example. There are a lot of opportunities within hydrogen. It not necessarily has to stay as hydrogen.
Right, that's an interesting point. Especially also the chemical industry needs a lot of hydrogen already now, which is now produced by gas reforming. You could substitute with green hydrogen, I would say, green hydrogen produced by electrolyzers. For instance, in refining raw crude oil into diesel and gasoline, they need a lot of hydrogen for that process.
Absolutely. This is a very interesting topic as we go then with the hydrogen as a biofuel and help the gasoline with its biofuel content, which is set by law today, that you have a certain content. And that's also quite interesting in the European discussion in the so-called Fuel Quality Directive, where we talk about biofuels, advanced biofuels, and hydrogen is in that discussion to become an advanced biofuel. And with that, you have a market entrance directly into that industry.
Another possibility, as you mentioned, is like you do in Falkenhagen, you put it just into the natural gas grid. You put the pure hydrogen into it, but that's downgrading in a way, isn't it?
At the moment, you're allowed to go up to 2.5, maybe 5% hydrogen content in the natural gas grid. It depends on where you do it. Technically seen, the industry believes that 10% is doable without major changes to the existing infrastructure. When you just inject hydrogen into the natural gas grid, of course it's all done by metering the caloric value so that the customer gets the same caloric effects for his money. You reduce the carbon footprint of the natural gas. It's marketed from E.ON under the name of wind gas. And that has a lower carbon footprint.
And this is also a nice business case that you can sell this gas, not directly, but like we do it in electricity. We buy green electricity. It still comes from the nuclear power plant next door, but we bought, well, the green electricity produced in Bavaria or Norway.
Yeah, you have to balance it, and basically you don't buy the pure molecules.
Same you can do with gas, yeah.
The same what you do then with the gas. You buy the content which is somewhere generated and get it out at a different point.
Which is an interesting business case for Audi as well, where you work together with them at Werlte. You have the electrolyzer there, and they say we producing e-gas, they call it, e-gas, and sell it to our customers, and they are more economically friendly than a pure electric vehicle.
Yeah, Audi did their calculations on that model to supply green energy to the entire fleet from gas to electricity. But we haven't done the electrolyzer, so I don't want to comment further on that.
Not in Werlte?
No, not in Werlte.
Sorry,
no.
I got the wrong information about that. Okay. But what you also do is, and you also pointed that out, you convert the gas into liquids, which is quite interesting, I think. Then you have a fuel, you have either methanol. You could even produce gasoline or diesel, couldn't you, with hydrogen?
I'm not an expert on how to convert hydrogen further down to liquids. For methanol production, we are already in a project where we deliver a 1 megawatt electrolyzer, and in the project the carbon dioxide will be captured from a conventional plant, and the electrolyzer will be run with renewable hydrogen, with renewable energy, and then synthetically we produce methanol, liquid methanol.
So we should talk really about power to X, not to power to gas anymore, because you can do so many different things with the gas. You can really well store it as well. But I always think if we talk about these business cases to store some surplus energy, renewable energy, and put it back to the grid, where's the business case? You know, is it using the surplus energy, or is it to providing power for the peaks that are needed?
The business case today is still a challenge because this is a pretty young business and business ideas, and the environment in which we work has not yet changed. For example, electricity in an electrolyzer, you pay the full amount of fees as you would pay in your private household. You don't get the price which is available and traded on the stock market. As the electrolyzer does not consume the electricity as an end user, but as a production unit, this is not a fair trade, and that makes the product at the end more expensive. So All I'm saying is we have to work on the regulation side to allow proper and valuable operation of the electrolyzer. On the other hand, there are legislations underway which already consider hydrogen and will benefit financially, that the hydrogen offers a more green energy carrier to the environment, and with that beneficial on the financial side, you will see business cases coming up very soon from now, which are under the given circumstances very difficult to find right now.
And as well, the green hydrogen should be acknowledged as biofuel, really, as the normal biofuel you can have from crops. It's even better than that, because it doesn't take any land, and it is not meals on wheels, as some say, yeah.
In the actual discussion, it is seen as advanced biofuels, so the second generation.
Okay, but it's also important that, in the future, that it makes a business case, it is counted twice or thrice as a biofuel.
That is the ongoing discussion, that we get some benefits due to the green nature of the hydrogen, of the renewably produced hydrogen, into it to help it with the business cases, because young technologies which have to step into the market and have to find their ways need some, in my eyes, in the industry eyes, limited from the total amount as well as from the time, limited subsidies to help getting started, to get into quantities, and as soon as you get in a certain amount of quantities, you have to achieve market pricing to survive without any kind of subsidies. Otherwise, it would not be a healthy business. And this is what needs to start now, because power to gas, we don't have to forget that we officially talk about power to gas for 3, maximum 4 years now, that it came up as a topic after Fukushima.
Very young,
and
yeah.
Now we are in the first projects. We have probably in Europe around 35 projects for power to gas under all aspects. That's not a lot. Yeah.
There's a lot of discussion about what is the best large-scale electrolyzer for power to gas. Some say it's alkaline because it's cheap. Some say it's PEM electrolyzers. What is your opinion?
We believe it will be PEM electrolysis. We have both technologies in-house. The alkaline electrolyzers we do for 40 years now, which is our pure standard product, which goes into the industry. Whoever has a need for hydrogen, like steel industry, coal, glass, semiconductor, oil and fat industry, they all need in the processes hydrogen. They typically use our alkaline-based electrolyzer. Very reliable equipment, runs for ever nearly. This is good, and it's sized for that particular market. For the larger scale, when we really talk about 50 megawatts, 100 megawatt, or even larger, size matters. That means I have to have need a compact footprint, and if you compare PEM technology with alkaline technology, and by the way, you can see a 1.5 megawatt stack at our booth, which is a mock-up. The original 1.5 megawatt is at the moment in our facility in operation before it goes to customer. The footprint is about 16 times smaller than an alkaline technology. And if you multiply that by 54 megawatts, you realize easily how compact a PEM plant goes compared to an alkaline plant. Plus, you have a higher dynamic behavior in the PEM electrolyzer. Even the alkaline is quite dynamic and good in dynamics, but the PEM is 10 times faster, roughly.
Okay, and size matters, as you pointed out, of course. But I also have heard it is a problem for the rapid change of the renewables. Sometimes it's getting up and sometimes getting down, and it's easier, well, to have a PEM. It's much more flexible electrolyzer than an alkali. Is that true?
I wouldn't necessarily say it's easier. Both systems, I can only speak for our products, they are always pressurized. We operate the alkaline electrolyzers at 10 bar and the PEM electrolyzers at 30 bars. So pressurized systems always have a quite dynamic behavior. Our alkaline technology is good enough to provide ancillary services to the grid. We have qualified our alkaline electrolyzers for frequency stabilization. That's the highest form of ancillary services or regulation services you can offer. That was done 2 years ago with an independent system operator in Ontario, following a second-by-second signal, proving that the technology can cope with it. PEM can do it even faster, but alkaline is fast enough, so both technologies can. And the ramping up, ramping down does not affect lifetime. Tests have shown that. We have several thousand hours of tests to see if degradation is impacted, and degradation means you lose conversion. When you get power into the cell, you get less hydrogen out, and by the degradation you can forecast the lifetime of your electrolyzer. There's no real impact through the big fluctuations you have with renewables, special with solar, which is much faster in its behavior than the wind.
I would like to give you the opportunity to ask your questions. If anybody has a question, please raise your hand. I'll be with the microphone right with you. Yes, there's the first one. If you just could introduce yourself, please.
Yes, hello. My name is Mario Schuster. I'm an IT professional, and I'm interested. So I'm new to this new market here, and I have a question regarding the hydrogen compared to the methane gas. How long can you keep it? How long can you preserve it in a tank, for example? Can you keep methane more than you can keep hydrogen? So can you keep it for 1 month, 2 months, or that's my question.
Yeah.
Thank you very much for that question.
So gaseous hydrogen stored in the right composite tanks can last there as long as methane too. It's not a problem. There was a discussion when we used liquefied hydrogen, because then you have always a bit of vapor and the pressure increases and you have losses. You have to get it rid. But gaseous hydrogen has no problems in storing it.
10, 20 years, he says?
I have no idea. I've never tested it for 10, 20 years. We consume it typically faster, but basically it should be not a big issue.
Okay. Second question.
I'm Björn Kulisch from RWE, utility company. I'm just wondering, how do you get out of this dilemma that utility companies are very slow in moving, buying electrolyzers, large scale, large stacks, and that you have the current regulatory framework working against you to promote your business selling electrolyzers more? So what's your current strategy for this? Trying harder lobbying the regulatory framework, or go into the market in your own market role as storage provider?
Thank you.
Yeah, thank you. That is a not easy to answer question. Of course, you have to act in all these fields you mentioned. You have to be active in lobbying, but this is not a negative lobbying. That is informing the government about a certain topic, advantages, and how to best use for the entire economy, and then try to figure out how to create subsidies or programs so that you can start with demonstrations, get the industry convinced in the technology, because it's the first step. Second step is then show that the business case under certain circumstances will work, what is needed to realize these circumstances, and then do the next logical move. It's not that easy to do, you know it by heart, but it's possible. And you see I'm pretty sure you're aware of the demonstration projects we run, and these projects of course help both informing the political decision makers about the technology and its advantages, as well as convincing the operators, which are classically an RWE, an E.ON, a Pitschak, or grid operators, to get trust in the technology and realize that the benefits are there. And now, together, we can move forward to target the business case. For example, we do first time and the first project so far in North America, together with Enbridge, which is a gas grid operator, and together with the IESO, which is the Independent Electrical System Operator. It's a 2 megawatt power to gas application, and this unit is under contract for of the IESO to provide to provide regulation services to the grid. So the IESO paying for it already, even if it is a demonstration unit, to see that the entire system is working. It's a 2 megawatt PEM electrolyzer in a 5 megawatt layout, so it has the potential to enlarge to 5 megawatts after a certain time in operation, and that is the next logical step then towards 10, 20, 30 megawatt systems. So the path is already on its way, and we're walking while we're talking.
Mr. Pitschak, last question, short answer, please. What is your biggest what's your biggest stack of PEM electrolyzers, and how much does it cost?
So it's 1.5 megawatt in its actual configuration. Price will be given in a 4i talk.
Okay, so I would like to invite everybody to come to your booth, Hydrogenics. You can just see it over there at C59, just opposite the public forum. I thank you very much, Mr. Pitschak, and time was running so quickly. We are out of time already. Thank you very much for your attention and for the talk with you, Mr. Pitschak.
Thank you.
Thank you. So next interview will be in 1 minute time with Steve Jones, Managing Director of ITM Power Incorporated, about hydrogen for California, the push for renewables. So stay tuned and keep sitting.